Okay, so today we'll talk environments, and we'll continue on our discussion. Let me. Oh no, that doesn't work. So I think we covered this stuff on Friday, wrapping up on scope. Here we have x, y, and z in the global environment, and within function f we define a function g. Within function f we assign the value 2 to y and the value 3 to z, and so when we call g, it adds x from the global 1, 2 from the execution environment f of y2, and then z is 3 here, and it adds those up and it returns 6. But the values in the global environment remain unchanged at 1, 1, and 1. Okay? And we looked at a couple other examples. Here, I've got 2 being superassigned to y in the global environment, 3 being superassigned to the z in the global environment. And when it asks for x plus y plus z, it takes the values in the global environment because it's searching the higher scopes and it doesn't find them until the global environment. So it returns 6. And in the global environment, the values are 1, 2, and 3. Over here, we have x, y, z being 1 in the global environment. We have the value y to be 2 in the local environment here. We superassign 4 to the global environment, and 3 gets superassigned all the way back up to the global environment as well. When we ask for x plus y plus z, it takes x from the global 1. It takes y from this environment f and takes 2, and then it takes the value 3 of z from the global environment. And so it's also going to return 6. And if we ask what are the values of x, y, and z in the global environment, those values are what? 1, 4, and 3. Exactly. Okay. And then we did not get to this one on Friday, but this is just to kind of show how super assignment works in terms of it keeps climbing scopes until it finds the value that it's looking for. So here again I have x, y, and z taking on the value 1 in the global environment. Within f, 2 gets assigned to y and 10 gets assigned to z. Here we use superassign, and we assign 4 to y in the global environment. So now the global environment has 1, 4, and 1 for z. Now when it goes to g, and we execute g, it's going to superassign 3 to z. It climbs the higher scope and it finds the z right here and changes this value to 3. Okay, so it's going to change this value to 3. So when it asks for x, y, and z, it's going to search for x and it won't find it until it gets to the global environment. When it searches for y, it will find it right here and we'll say y is 2. And when it searches for z, it will find this z in the function f, and this value has been modified to 3. So it's going to return 1 plus 2 plus 3, and it returns 6. In the global environment, we will have the values 1, 4, and z will remain 1, because this supersign affects only this z and does not impact the z up top here. Is that okay? And so in the global environment, we have 1, 4, and 1. Question?
So technically z doesn't exist within the function g?
Yeah, z does not exist in the function g. It's when you search for z, it looks for it inside here, and it's not there because the 3 has been superassigned. Superassigned does not create it in the local scope. It creates it in the higher scope, okay? Or it tells it to start searching in the higher scope, okay? So that's why this 4 does not overwrite this 2. You get a 2 value of y equals 2 inside f, and this value of 4 being assigned to y completely skips this y and goes directly to the global environment. Is that okay? All right, so we've done a bunch of examples, but the takeaway that I want you to have is avoid super assignment. And some of you guys have started your tic-tac-toe, and I don't know if you're starting to use super assignment anywhere in your tic-tac-toe thing, but I strongly encourage you, do not do it, okay? And if you started using tic-tac-toe, then you should probably make some modifications so as you do not use super assignment. The super assignment is useful in teaching how scopes and environments work in R, and we'll talk more about scopes and environments in today's lecture, but it's not something that I recommend on a regular practical basis. They do play a role in something called reference class objects that exist in R, but other than that, I don't recommend the use of super assignment. So for example, let's say you wanted to create a function that all it does is it takes in this argument foo, and you're going to give it the value x, and it will just tack on x squared. So if foo is currently like 100 and you give it x is 9, you want it to do 9 squared and do 100 comma 81. And then if you have 181 and you give it 8, then you'll want 8 squared tacked on, and it'll go 100, 90, 81, 64, so on and so forth, or something like that, okay? So here is what somebody might try to do to super assign, to modify the value of foo in the global environment, okay? So we're gonna say take foo, tack on x squared, combine it with x squared, and super assign it back to foo, okay? So here I'm gonna say foo is 2, and then we run the function add square bad version, and we're going to take foo, which is currently 2. We pass it the argument 5, and so that's going to take 5 squared, 25, and it tacks it onto foo. And when we ask what is the value of foo, it says 2 and 25. Okay, and that seems like it works. Okay, this seems to be doing what we want it to do. Okay, but because we've used super assignment, it does things probably that we weren't anticipating, okay? So for example, here I create something called bar, and it's 10, okay? And here we're gonna do add square, and I take bar and I do 5, okay? And so I'm expecting to get 10 and 25. 5 squared is 25. I expect 10 and 25, but when I ask what is bar, it gives me back 10. And if I ask what happened to foo, foo has been modified to 10 and 25. So what happened is back in over here, I pass it the argument bar. So this comes in, and so bar is 10, and we have 5 squared 25. And so this combination of 10 and 25 gets super assigned not to bar, but it gets super assigned to foo. All right? Is that okay? So what's going on here? So bar remains unaffected at 10, and foo takes on the value 10 and 25. And so this is probably not what we want, okay? And the problem is that the assignment operator happens inside the function, okay? And when things happen inside functions, it's unclear what is happening, okay? And if you were trying to debug this, and try to figure out what's going on, you would have to know that there's some kind of super assignment operation happening within this function. And if you had forgotten that, okay, which is quite likely if you take a break from your work and you come back working on it like 2 days later and you've forgotten where all the super assignment happens, it's going to be very hard to track down why foo is being changed over here when there's no reference to foo being made over here. Okay, and you'd have to know that, oh yeah, inside this function, I'm super assigning something to foo. And if you didn't recall that, which is very likely to happen, especially if you take a break from your project, it's going to be hard to know where this thing is happening. Okay, so the correct way to do something like this, okay, is to not do any kind of assignment within the function. Okay, and so the function will take in arguments and it will return something, but it doesn't do any kind of assignment inside the function. So here we're just going to say take in the argument Baz, tack on x squared, okay? And because this is the last line in the function, this is going to be the value that gets returned. So it's just going to return Baz and x squared. So if Baz is 9, and we say add square, it's going to return the value 9 and 25, okay? And if we ask, well, what is Baz? Baz remains 9 because we did not save this output, okay? It just returns the output, but there's no assignment being done here. So 9 and 25 gets returned, but it's not being assigned anywhere. And so if you do want to update something, then that operation will have to be made explicit, okay? So here I've got foo again. We're going to do 2, we do add square, and we do foo 5. And here the assignment of saying the output of add square good gets assigned to foo. And so now foo takes on the value 2 and 25. And so if you run into a problem later and you say, well, why is foo taking on this value? It's very clear and easy to see in your code that this is that we are taking the output here and assigning it to foo, okay? So the assignment is being made explicit in your code, and it's much easier to track down any kinds of problems or mistakes, okay? Over here with bar, we do add square bar 5, and we explicitly say assign it back to bar, okay? And so this is going to be something probably that you encounter in your tic-tac-toe. You have, like, for example, well, if you follow my recommendations, and you don't have to, but one of the things is, you're keeping track of the game in the state object, right? The state object is some kind of vector of 9. And like if somebody makes a move, you want to update the state object, right? And so I would say the update function should not do any kind of assignment within the update function. You just take in whatever arguments or parameters are coming in, and it returns an updated state, okay? But there's no assignment there, and so what you will do instead is take that updated state that is returned from the function, and you will assign it to the current state variable, okay? Much like this. You will take in the arguments, and you will say update the state, and then you will take that returned object and assign it back to the state. And that's how you will update the state. Rather than just having the assignment happen within the function, which seems great at first, okay? Like, this seems like it's working at first, but then when it starts behaving badly and you're not quite sure what's going on, it's really hard to track down if the assignment is happening inside functions. And so if you keep the assignment happening outside the function, it's a lot easier to track down any kind of mistakes and errors. So that's my recommendation to avoid using the super assignment there. Okay, we're going to spend some time today talking about environments, all right? And we've got to see a little bit of this already, and this kind of just formalizes a lot of this. I've directly, I don't want to say stolen, but I've directly taken these pictures that were created from Hadley Wickham's Advanced R textbook, so that, if you're reading his textbook, these pictures are going to be very familiar and whatnot. So, but I think he does a great job of explaining it. I really can't do a better job here, okay? And so the environment, and when you start off R, you default to working in the global environment. And what these environments do is they associate names to values, right? So when you say take the value 2 and assign it to A, it's taking that name A and it's associating it with the value 2. All right, and so an environment, you can think of it as kind of this bag of just names. And here, when we say we want to assign these values to these things, they're being associated with just these different values. And so here we can explicitly create something called a new environment. If you just do A false assigned to A, excuse me, in the global environment, it's the same exact picture, except it's not $A, it's just A inside the global environment. Okay. Every environment has a parent environment, okay? And in these diagrams, the parent environment's indicated by this black dot pointing to another box here. and the parent environment is just the higher scope, and it keeps going all the way until the very end, which is known as the empty environment. So the global environment is generally where you're doing your work, but the global environment itself has a parent environment, all right? And that will just generally be the package namespace of the last loaded package, and we'll talk about that, but it climbs up until it reaches the empty environment, which is going to be the only environment that has no parent, okay? So the kind of the most commonly used one is the global environment. This is your regular old workspace. And the parent of the global environment is the last package that you attach with library or require or something, right? So when you load a package and you're going to use ggplot2 or something, and you say library ggplot2, the last package that you attach using library is going to become the parent environment of the global environment, right? The base environment is the kind of the base package that has all of the functions that we're accustomed to seeing. All of the, like when you start up R and you have functions like C, combine, okay, that allow us to do things, that name C exists within the base environment, right? So C is kind of probably one of your most important functions inside R, and that exists inside the base environment, okay? The empty environment is an empty environment, and it's the only one without a parent, and if you ask for environment, it's the current environment. So when you, if you type in the word search, parentheses, this function, it will tell you all of the parent environments, okay? So right now we've got global environment, its parent is package stats, its parent is package graphics, and it keeps going until it reaches package base, which contains like your base functions for R that allow you to do things. Okay, this is what the kind of the search path visual looks like. All right, so when you're inside R, and if I check, does C exist, okay, inside the global environment, right? So this is what I've got in the global environment. If I ask, what's in the global environment, it tells me there's nothing in the global environment. But I can ask, is there this function C, and it exists, right? And I can obviously use it, and I can like combine the values 9 and 3, and that's because when we type in the word C, it starts searching in the global environment. It's not going to find C, and it keeps going all the way until it reaches, base, right? Package base, and this is where these base things go, right? So if you type in like where is C, right? If you ask for help on C, it's going to say C is located in base, meaning the base environment. Yes.
What is the last variable?
Last variable. So this is something I like to use because sometimes you'll do a calculation and you forget to explicitly save it somewhere. So like you'll do like I don't know, you'll create some object 4, 4, and 5, and then later on you're like, oh, I wanted to save that. And instead of rather having to retype the thing, you can just call .last.value, okay? And that will just pull up whatever it was. And so if you wanted to assign this, you can then say, I want to save this as object D or something like that. Okay. Yeah. Question.
Did you upload the images that you're using in the?
Oh, you know what? I had to do that. I'll do that after class. Okay. I apologize for forgetting to do that. Okay. So anyway, when you call for something, other functions like lm. Okay, lm, again, you can use the linear model function. This exists inside package stats, okay? So when you ask for the help on the thing, it'll tell you where these things are. And right now, my search path says, it's going to start in the global environment. Oh, there's some functions that exist, but there's package stats. And so it's going to search for lm, and it's going to search for it in stats. And when it finds it in stats, it's going to use that thing. and it's going to keep going until it gets to package base. And so these are kind of all of the things that have loaded up, right? All right, is that okay? So that's why you can use all of these functions in R even though we haven't defined anything, because they have been defined and they exist in these other packages that exist in our search path. And when we call for something, just like when we called for the value x within the function and it couldn't find it, it kept climbing it until it reached a higher environment, the search path will search for the function c until it finds it in the base environment. Which is also why if you define a function called c over here that takes in some value and then you say, print hi, okay? So here I've defined a function c, and so now if I try to do like combine 9 and 4, it's going to give me an error because it thinks I'm referring to the function c in my global environment and not the real c that exists in the base environment. So if you a lot of names are not protected in R. A lot of these things that exist in the base environment are not protected in R. So you might accidentally create a function that has the same name of something else. I think there was a question on Piazza about the return function not working, and I think it's probably because somebody accidentally made the same function name. Yeah, question?
Can you change the orientation of the search path?
Can you change the order of the search path? So you can load packages, and that will determine things. I want to say if you want to change the order of the search path, basically when you start R, it's going to load up all of these packages, and I don't know if you can change the order of those. I'm sure there's a way that you can configure your R startup to change it, but I don't know about off the top of my head. But generally, within this regular search path, none of the names will conflict with each other here, okay? And it's just when you start, like if you load package, dplyr and other things, you'll get a warning, right? So if I say library dplyr, it's going to say we loaded a couple functions, and one of the function is named filter, okay? And so there is, and there's some functions in base, right? And so the function filter is very useful in dplyr, and we'll learn about it later. But there's also another function in package stats called filter, and so because we've loaded dplyr, it's going to mask these object names, okay? And you can reference, you just have to use the double colon notation, and I can ask for filter from package stats. But generally when you type in the name filter now, it's going to look at the one that exists in the search path. Okay, functions. So when you execute a function, it will create an environment, its own function environment. And there are 4 environments associated with a function. Okay, there's the enclosing environment, the binding environment, the execution environment, and the calling environment. Okay, and pretty much the enclosing environment and binding environment will be exactly the same for any function that you create in the global environment. Okay, when you create a function, the environment where it is created is called the enclosing environment. Okay, where that name exists is the binding environment. Okay, and so when you create a function and it gets created in a script and it exists in the global environment, the enclosing environment and the binding environment are going to be exactly the same. There's only a difference when you start getting into creating R packages, and because the package exists somewhere else in the search path and yet the function exists somewhere else, like then you have a slight discrepancy. But in our class, I'm not going to have you be making R packages, and that's probably something that most of you will not have to worry about. Okay, if you go for graduate level courses, then maybe it's something to check out. Okay, but anyway, where the function is created and stored, that is its enclosing environment. The execution environment is an environment that gets created only during the running of the function. So when the function runs, it creates its own execution environment, and that environment exists only while the function is running, and it disappears afterwards. Okay? If you have a function and you call a function from inside another function, then the environment where the function is called the calling environment. Okay, and there's some differences there. Okay, so I think this is what I just said. The enclosing and binding environment is the same in most scenarios. Okay, so here's a very, very simple function. Okay, function f is a function of x, and it returns the value x plus y. And we assign the value y in the global environment. So this is our picture. Y takes on the value 1 in the global environment, and here's function f. Okay, when I call, I'm going to go ahead and skip that for a second. Okay. When we call a function, so here's another function, okay, called h, and inside h, I'm going to assign the value 2 to a, and I'm going to return the value x plus a. So here I'm going to call h of 1 and assign that value to y. So this is what our picture looks like. Inside our global environment, we have the function h, okay? And when we call h with the value 1, this is the execution environment. This is a separate environment that gets created for the function h as it's running, and it assigns the value x to 1. Within the function x, the first line then assigns the value 2 to a. It associates a with the value 2. Okay, so when it gets called, it automatically creates x as 1. Okay, and now the function says return x plus a. All right, so it's going to combine 2 and 1, or add those two together, and gives back the value 3. And this execution environment disappears. It disappears, and now we have assigned the value 3 to the name y. Okay, and so everything that gets created here, the x and the a and all of that stuff over here, exists only during the execution of the function, and it all goes away once the function stops running. Okay, yeah, and I think I mentioned this very briefly. Enclosing and binding environments only make a difference when we're talking about package namespaces. 99% of the time, you don't have to worry about this. 99% of the time, you can assume the enclosing and binding environments are the same. Okay, and the calling environment, okay, is, again, if you call a function inside another function, then the function where you called that function is the calling environment, okay? When R performs its scoping rules, it will search not through the calling environment, but it will search through the global, it will search through its parent or enclosing environment, okay? And so I've got a few examples that make some distinctions here, okay? So I have quiz questions. I don't know, do you want to do, use the clicker things, or just, will you answer? I've got, okay, all right. Not for credit, but for fun. Okay. All right, so here, let's just try a few of these things out, okay? You can expect to see questions like this on the midterm exam. People are asking, like, what does the midterm exam look like, okay? And it's going to be stuff like, I write some code that is purposely a little bit weird, okay? Not like, obviously straightforward code you guys all know how to do, right? But I write some code that's a little bit odd and makes you think, and then I'm going to ask, what will this code output? So anyway, here I have defined x and y in the global environment. X is 0, y is 10. I define a function g. Inside g, x takes on the value 2, and y takes on the value 100. And inside g, we call the function h, okay? we call the function h. Okay? H is defined in the global environment. Inside h, x takes on the value 3, and we return the value x plus y. Okay, so the first question is what will, oh, this didn't get formatted correctly, but what will h return? Okay, what will h return? So I'm not even calling g. Okay, we're going to ask what does h return? So if I execute h, what will it return? It will return 13, okay? Because x takes on the value 3, it searches for y in the global environment, and it says takes on 10, okay? So when we call h, it takes on the value 13. Okay, next question. Sorry, it didn't get formatted correctly. What will g return? So if I call g again, g assigns x to 2 to x, y to 100, and then it returns h, okay? So what does g return? 103, 12, 13, what? So g will return 13, okay? So what's going on? Here, h is being called inside g, but h is defined in the global environment. H is defined inside the global environment. So when it comes to this point of asking what is the value of y, it searches its parent environment, the global environment, and searches for y inside 10. It searches for y in the global environment, which takes on the value 10. Okay? So these things, they're here to distract you, okay? They have no bearing on this x, what happens inside here. So x takes on the value 3 inside h, y takes on the value 10 because h is defined inside the global environment. Yeah.
Can you define a function within another function?
Yes, and that's my next thing. Okay. Right on, one step ahead of each other. Okay. So here we have x and y being the same as before. X is 2 and y is 2 inside j, and inside j I define h. Okay, I define h here. So h is now defined inside j, and so here I'm going to we're calling h here. We're calling the function h, but we define h inside j. So what is this going to return? It's going to return 150, exactly, okay? Because here, when we call h here, we execute this h, the h inside of j. X takes on the value 50, and then when it looks for y, it searches its parent environment, which is not the global environment, but because it was defined inside j, it takes on the value 100, because the parent environment of this h function is j. Yes, question?
If you call the h function 1 after that last...
So if I called the h outside of j, then it will run the h that's defined in the global environment, right?
If it wasn't defined in the global environment...
If it wasn't defined in the global environment, then I'd run into an error that says h is not found, okay? Because this stuff exists only inside of j. It only exists when we execute j, okay? So this h only exists when I execute j, and it doesn't exist outside of it, okay? All right, I've got more examples that were just too hard to format to fit our the slides here, okay? These are all like, I don't know if they're fun. I think they're fun, okay? Are you able to see this? Let me see, what can I do in terms of making this bigger? Okay, let's zoom to 175. And if you're seated far away, I think I uploaded this and you can see it. Okay, so here, right now my global environment is empty, okay? We're going to assign the values 1 and 2 to a and b. And here I define the function L where I print out a and b. And so when I run this should be no surprise. It's going to print out 1 and 2, right? Okay, so that's not a big deal. Okay, so here's M. So again, A and B take on the values 1 and 2. And inside M, I define the value, I assign the value 4 to A, and I call L. All right? So what is this going to print out? 1 and 2, because when I'm calling L is defined inside the global environment, and so it looks up the values 1 and 2 in the global environment, or it looks up the values A and B in the global environment, not the A inside of M. Okay, which I think we demonstrated that earlier, right? Okay, so here I think we've seen similar things here. Okay. Inside N, I've got function A, not function A, I define A to be the value 4. And inside N, I define the function L, which prints out A and B. So again, in the global environment, A is 1 and B is 2. And so now I call L within the function N, and I've also defined L inside N. So what will this print out? 4 and 2, right? So when I call this, I get 4 and 2. Okay. Here is, this one's a bit of a doozy here, okay? So here I'm defining function O, okay? Inside function O, again, A and B are 1 and 2 in the global environment. Inside function O, A takes on the value 4, okay? And I'm going to call L 3 times inside of function O. So the first time I call L has not yet been defined inside of O. So when this runs, it's going to run the L that's in the global environment, and it will print out, and it's going to print out A and B. So it's going to look up the values in the global environment. It's going to print out 1 and 2. Then I redefine L inside the environment O, okay? I redefine L inside the environment O, and then I call L again. And so now that L has been defined inside the function O, when I call it, it's going to use this L, and it says print out A and B. And so it's going to take A from 4, and B will be the global environment value and take on 2. And then I define B to be 5 inside of O, and I call L again. And so now it's using this same function L here, the one that's been defined inside O, and it asks for the values A and B, and A and B are now both defined inside O, so it's going to use 4 and 5. So what we're going to see is 1, 2, 4, 2, 4, 5. Is that okay? So that's what we get, okay? When we call O, we get 1, 2, 4, 2, 4, 5. We're calling the function L 3 times, but each time, this time, this L is the global environment, this L is the one defined inside O, and when we call it again, it's still using the one inside O, but the values that A and B refer to are changing, right? It's using the, so I've tried to document all of this inside the comments here, okay? And if you get a handle on this, then you've got, I think, a pretty decent grasp of how the scoping rules inside R work, okay? It's going to keep searching for the thing, up the search path, and again, it's looking at its parent environment, okay? And the parent environment is where the function is defined. All right, is that all right? Okay, and then the last bit is I wanted to cover dynamic scoping, okay? And you will not be tested on dynamic scoping, okay? But it is interesting because we'll do something similar, but dynamic scoping allows you to refer to objects in the calling environment and not the enclosing environment, okay? Here, and let me actually, I'm going to go back and I'm going to just copy these functions again. Okay, so when we did not have dynamic scoping, I'm going to just do rm list equals ls. Okay, so when we didn't have dynamic scoping, we had x is 0, y is 10, and we have h takes on this thing, right? X is 3 and x, and it returns x plus y. And so when we call h, it returns 13. Okay, no surprise here. And when we call g, it also returns 13 because it uses h's parent environment. So here I've got g, and inside g, we call the function h inside of g, and there's no dynamic scoping going on here. So when we call h, it uses the h's parent environment, which is the global environment. Yes?
If h in that function had the inputs of x and y, which x and y would it choose?
If you input the value x and y, then it would use the x and y that's inside of g, okay? Because those would get passed into it, all right? Unless, all right, so I guess there's a few, it depends where it's positioned, right? So if you had h, x, y here, then it would use the x and y in the global environment. But if you use h, x, and y here, it uses the x and y that have been defined inside of g, okay? So it depends where in the listing it's calling, right? And this is the blessing and the curse of R's, generous scoping rules, is that a lot of other programming languages will say, what have you done? I am going to stop working, right? And R is going to say, I don't know what this is. Let's do my best, and it searches, right? It does scoping and it searches for these things, and so it just means you also have to be careful not to screw things up, right? So anyway, so here, x and y, and we're not inside h. H references x and y, and it uses not the values inside g, and so when we call g, it returns 13. Okay, that's fine. All right. Here, we're going to have x and y being 0 and 10. And here, instead of this, I'm going to use this I'm going to define something called p, okay? And inside p, we use this function called get, okay? And when you say get parent frame, this references the calling environment, okay? It says don't take y from the I know it's confusing because it says parent frame, but it's saying don't you take the y from the global environment, which takes on the value 10, but search for y inside the calling environment, okay? And so here, and then x takes on the value 3, and we return x and y. So if I call p in the global environment, it's going to search for y from where it was called, and it's going to find 10, and it's going to return 13. Okay, so p takes on 13. All right, and this is where it's now different. Okay, so R looks almost exactly the same as G over here. Okay, but the subtle difference is that with P, we're saying when you search for Y, don't search the where P is defined, but search for it inside its calling environment. So when you call R here, no, that's not correct. What happened? It was supposed to be 103. Let's see. Why did I do this? Okay.
Calling P, not R.
Huh?
You're calling P, not R.
Oh, I'm calling P, not R. Okay, that explains it. All right. So now when I call R, it returns 103. Okay, there we go. Thank you. I'm like, what am I doing wrong? Okay. Yes. So when we call R, it returns the value P, but when it runs P, it's looking for the Y from the calling environment, and it uses 100. Okay, so when we call R now, it it's 103. Okay, and so that's an example of dynamic scoping where it uses the values not in the environment where it's defined, but in the environment from where it is called. Okay, don't worry about it. You will not be tested on it, but because I made such a point of it in the lecture notes, I wanted to give you an example of it working here. Okay, all right. We'll end there for today, and please study all of this environment and scoping stuff.
Will you update